Hi guys, today's notes are on 9.5 and we'll be graphing cosecant and secant. So the first thing I want to remind ourselves of is what is cosecant, right? So remember, cosecant is the inverse of sine, and then secant is the, sorry, not inverse, reciprocal of cosine. So the characteristics of secant and cosecant, just so that we have them written down. Cosecant is the reciprocal of, oh, I should have written it here, sorry. And secant is the reciprocal of cosine. And sine is always y, so it's going to be 1 over y. And cosine is x, so it'll be 1 over x. And so the trick to graphing secant and cosecant is to actually graph and put everything into place as if you were graphing a sine function, and then at the very end we do something a little bit different. Okay, so let's take a moment and graph the sine function. I'm going to do that in blue, and then I'll end up putting the cosecant graph in red. So we know that sine, let's think of it not as 0, 0, but we're going to start at the midline, which does happen to be 0, 0. It's going to go up to 1 at pi over 2. And we're going to come back for a period of 2 pi. Okay. And then I'm just going to extend my graph. On the assignments so far that we've had, I've had you guys do this where you draw the maximum and minimum lines in there, because that'll help you establish some boundaries that you never go past. And so these will be helpful today as well. Okay, so let's now, once I have those in, I can very quickly put my points in. Okay, so I'm going to put some dotted lines in. Hopefully there's not too many dotted dash lines in here for you guys. Okay, so that's my sine, and I'll label that as sine of x. It's our parent function, right? So that should look really familiar. And cosecant, I should have flipped those, I'm sorry, because we're doing cosecant first and then secant. Okay, so cosecant is the inverse, or the reciprocal, right? So if we're at 1 over 1, the reciprocal is still 1. So this point's going to stay the same. The reciprocal of -1 is still -1. And so these points are going to stay exactly the same. The 1s and -1s. Okay. However, we now have a problem, because if we take the reciprocal of 0 here, that's our y value, we know that the reciprocal of 0 is undefined. Right? Because we can't have 1 divided by 0. And so at these points here, what you're going to have are asymptotes. They're undefined values, so they do not exist. Okay, so I'm going to write here undefined. Oops. And then here as well. So anywhere there was a 0 for our sine graph, 1 over 0 is undefined. Okay, so this is a little bit different now. And then let's see if we can visualize this a little bit better. Let's take a look at a triangle. Let's see if this helps. And we're going to focus on y, and the reason I drew it this way with a 30 degrees is because sine of 30 degrees equals to 1/2, right? Like this is 1/2 here. And 1/2 is a nice easy number. So that means that this point right here is pi over 6, right? Because pi over 6 is 30. Okay, so right here, if this is 1/2 and it's pi over 6, then my cosecant graph has to be the reciprocal of 1/2, which is 2. So if we take this, and I should have doubled it, there's my 2. That means here, instead of being at 1/2, I'm going to be up at 2. Oh, next year I need to fix this graph a little bit better. Okay, so if I extend my graph here, hopefully this helps a little. So there's my 2 value. Okay. And if we come over here, and on the other side of our unit circle, right, we have another triangle here, and our y is 1/2 here. That means I've traveled pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, which is like somewhere here. Then this point also becomes a reciprocal, and it goes up top. Okay. And so what really happens, this is just the only time we're going to do something like this, is that the graph you have is going to look like a U shape, but instead of like a standard U shape that will go wider and wider, this graph will approach the asymptote and then start to level out. Okay? And so over here in this section, since this is exactly the same, right, it's a period that repeats, we're also going to have this graph. That gets closer and closer to the asymptote, but never touches. Now, how do the ones underneath go? This one will also do this, right? The ones underneath are going to start at -1, and they're still going to get close to the asymptotes and never cross over. Okay. But it's going to look like this. So I want to take a moment and just establish that if you're doing this in pencil, you've got a lot of lines on here. I'm going to actually bold this, and this is what I want you to do right now, is to take a moment and make all of your cosecant graphs a little bit more bold. Since I have red that's easy to see, I want you guys to either use a highlighter or make it darker, okay, because this is what you actually want. Now, luckily, that's as complicated as it gets. Cosecant is going to be exactly the same, except everything is shifted to the right, right? So now, if I had my cosine graph, I would start at my maximum, which is 1, go down, -1, right, back up. And so we have this cosine graph. And if I were to graph the reciprocal of this, sorry, I'm doing this a little fast here. If we were to graph the reciprocal, you need to show your asymptotes. But notice the asymptotes are in a different place now. Right? So they're at pi over 2, 3 pi over 2. It would be at 5 pi over 2, 7 pi, right? Every other, it's still 1 pi apart, but they are at the pi over 2s versus over here it was at 0, 1 pi, 2 pi, 3 pi. Okay. And then the graphs are the same too. You're going to have a U shape that doesn't touch your asymptotes. And so once again, when you draw this, please take a moment to highlight which graph we're talking about. Okay, so let's talk about domain and ranges. The domain is all real numbers except, and I don't need odd, because it's all multiples of pi, right? So there's 1 pi, 2 pi, 3 pi. Domain of secant is all real numbers except for the asymptote, which are odd multiples of pi over 2. At these x values, pi, multiples of pi, and multiples of pi over 2 that are odd, the graph has vertical asymptotes that you have to draw in. The range of each function, okay, is y is greater than or equal to 1, and y is less than or equal to -1. So the graphs don't have an amplitude because they go forever. Okay. Now we can say that the period of both graphs is 2 pi still. Okay, do you see how there's one up and one down? There's one up, one down, so it's still 2 pi. Okay, not sure what this one is. Let's cross that out. Okay. So how do we graph secant and cosecant? The parent functions look exactly the same. We're first going to graph either sine or cosine, and then you're going to use the asymptotes and several points, which are at 1, to sketch a graph of the function. Okay, so let's take a moment and practice this. It starts off the same, and so when you fill out these first few points, you are going to use secant is 1 over cosine, right? So you're going to use cosine of x to fill these out. So as if you had 2 cosine of x. Okay. So notice I used the same function. I just swapped out secant for cosine so that I know like what I'm going to do here. So our midline is going to be y equals 0. There's no k value, right? Amplitude is 2. Now, the amplitude of cosine is 2, but here we said there's no amplitude, right? So that's why we're using cosine of x here, because the amplitude is going to help us determine where's that empty space in here. The maximum value of cosine is going to be 2 above the midline, mid plus, or instead of mid, I could just call it k, right? K plus a, and then k minus a. So it'll be 0 plus 2 and negative 2. Okay, so let's draw this in real quick. I've got 2 here. I have negative 2 here. My midline is in the middle. I'll put a 0 there. The period of this graph always starts at 2 pi over b. b is 1 right now, so it's just 2 pi. And distance between critical points is divided by 4. So this is going to be 2 pi over 4, which is pi over 2. Okay. So that means I want to count by pi over 2's. Half of 2 pi is pi. Half of pi is pi over 2. 3 pi over 2. Number of cycles in 2 pi, this is divide by period, right? So 2 pi divided by 2 pi equals to 1, which makes sense because we're going to go 1 whole cycle to 2 pi. If there's a phase shift, you would write this in. It'd be in parentheses here, but there is none, so this is x equals 0. So I can draw in my starting values here, right? This is my like phase shift. Okay. So now let's graph cosine. I'm going to do that in blue, and then I'll do the rest of it in red. You guys okay with this? I'll do another one here just for the heck of it. We know that the cosine is going to look like this, but this is not helpful except to help guide our asymptotes for secant. So now, anywhere there's a 0, or anything that passes through the midline, I should say, has an asymptote. I'll do another one over here just to show what we've got. And then you're going to go from the point at the max or min, get close to your asymptotes, but do not touch them. So how do we do critical points? Well, our first critical point is at 0, 2. This one, we want to use 2 secant x, okay? And I'll put that in on the quiz or test. So 2 secant x, the critical point is at 0, 2. The next one is that x cannot equal to pi over 2. That's an asymptote. The next critical point is at pi and negative 2. And then the next point is that we have another asymptote. X cannot equal to 3 pi over 2. And the last one is at 2 pi. Notice that this always matches like our period, right? From 0 to 2 pi is 1 period. And then we will have back to 2. Okay. We'll do one more to practice, or one more example that's a little bit more complicated, and then you guys are going to practice too, to try. So this one I've thrown in translations that are horizontal and vertical. So once again, we're going to establish that the reciprocal of cosecant is sine. And so we're going to use all of this, but as if this were sine. Okay, so let's practice. This is as complicated as I can make it. So the midline is going to be at k, which is y equals 3. 1, 2, 3. I'll put that in right away. Our amplitude is, the a value is -2, but it's an absolute value, so it'll be 2. The maximum is k plus a, which is, or k plus absolute value, right? Because it has to go up from 3. So it's going to go 2 above 3, which is 5. And then it's going to go 2 below 3, which is 1. Okay, so here's our established values to help us graph sine. Okay, we know the period is 2 pi over absolute value of b, which is 2 pi over pi this time, because b is right here, pi. So that's 2. Here's our period. Distance between critical points, divide by 4. So it's 2 over 4, which is 1/2. Okay, so this looks sort of similar to what we were doing before. Number of cycles in 2 pi is 2 pi divided by the period, which is 2. So there's going to be pi cycles in 2 pi. That's actually not helpful right now because we don't even have 2 pi on our graph, because that's around 6 point something, right? This one is the most complicated because it has a phase shift. So there's a horizontal shift here. You see how b is factored out. So my horizontal shift is x equals +1. We switched from negative to positive. So I need to imagine that this is my new x-axis. Okay. So we know that we're graphing sine, which means we start at the midpoint. But since it's a -2, we're going to go down 2 first instead of going up. Okay, let's see. 3 pi, this is 5 pi over 2, or 5 over 2, sorry. And since I can't fit the whole period there, I'm going to just follow my pattern and go backwards. And you want to make sure that you extend your graph all the way to the edges of your graph. Okay. Well, that was my first vertical asymptote. Here is my second. There's one here, right? Anywhere that it goes through the midline, there's going to be an asymptote. So critical points, I'm going to start here because that's where I shifted to. So that's an x value of 1, and my midpoint is at 3, or midline, I should say. Oh, sorry, just kidding. That would be great for sine, but for cosecant, at this point there's an asymptote, so I'm going to say x cannot equal to 1. Okay. There's going to be a point here, and then this one will be x cannot equal to 2, and x cannot equal to 3, right? Like if I continue the pattern, there'd be asymptotes at 1, 2, and 3. Okay, so at this point, we're going to go to 3 over 2, and it goes down to the minimum of 1. We come back for an asymptote, and then we're going to hit another point of 5 over 2, comma, 5. And so now we should probably draw in our cosecant graph. We don't need additional points on here just because it's too difficult to get accurate points. Okay. But that's pretty much it. So 2 things you want to be careful of. Make sure that you graph your phase shift first, and then remember that if it's a negative, you go down from the midline. If it's cosine, it means you start at the minimum. Okay? There are 3 problems for you to practice right now. We will check them in class, but please try them and get as far as you can before you move forward.